Hello everyone. This is a brief introductory video to the course POLS 398, Advanced Political Science Methods. I'm Ross Burkhardt, Professor of Political Science in the School of Public Service at Boise State University, and I will be your instructor for this course. We will focus our efforts in the course on mastering the technique known as regression analysis, which is a workhorse quantitative research methodology in the social sciences. What is regression analysis? The basic idea of regression analysis is to find the best fitting line to a set of data points. We use mathematical techniques to find that best fitting line. I will illustrate one of those techniques in detail in a couple of weeks called ordinary least squares or OLS regression. For now, just know that there is a mathematical method to finding the line that you are looking at right now. The line is on a scatter plot of data points that measure for every presidential election since 1948 over 19 elections, the percentage of vote that the incumbent candidate, or incumbent party if the incumbent did not run for re-election, received from the total vote for the two major party candidates, Democratic and Republican, and the approval percentage of the president's performance in June of that election year. We hypothesize that the greater the approval of the president's performance, the higher the percentage of the vote received by the incumbent party's candidate in the election. And if we follow the path of the line, from bottom left to top right of the scatter plot, we see that the data points follow that line, with 2 points touching the line and another 9 points coming very close to the line. The line can be described by the algebraic equation y hat equals a plus b sub 1 times x sub 1 plus e. We will be defining these terms extensively, but immediately we can see that the equation is short and precise, one dependent variable and one independent variable. The r-squared value of 0.67 tells us just how well our line fits the data. In this instance, we see that 2/3 of the variation in incumbent two-party vote is explained by variation in presidential approval, which in social science research is a relatively high r-squared. How much of a workhorse is regression analysis? An article published in 2008 in the research newsletter The Political Methodologist provides a good answer. Out of nearly 1,800 articles published in the top 3 political science journals, American Journal of Political Science, American Political Science Review, and Journal of Politics, OLS regression analysis, the kind of regression analysis that we will be learning, was the single dominant quantitative methodology employed in them, easily winning a plurality of the uses, 31% of the articles, more than double the next most popular method. Why is this the case? The authors of this article, James Kruger and Michael Lewis Beck, suspect that OLS, quote, offers common coin, easily exchanged among most scholars in the discipline. It is simple to run, simple to understand. And simply stated, its appeal is in its clear procedure based in the logic of minimizing something called the sum of squared errors, or deviations from a regression line through a set of data points. We will be exploring the intricacies surrounding regression analysis, from why least squares works, to techniques to adjust the procedure based on the idea of violating regression assumptions, and many more ideas. You will become more proficient in the craft of regression analysis and interpretation, which will prove useful to you in your professional lives, and as consumers of political information such as polling reports, policy analysis, probabilities of war and peace, and others. In short, this exercise has intrinsic and extrinsic appeal, and you will be able to understand the equation on this slide. To pay homage, here's a brief glimpse of the inventors of regression analysis. Carl Friedrich Gauss was a preeminent German mathematician and physicist who was well known for algebraic theory and astronomical discoveries, in particular calculating orbits via his invention of least squares. Adrien-Marie Lejeune was a French mathematician with only one known portrait, the rather unusual one that you're looking at. And here's some trivia about that portrait. A politician named Legendre portrait was incorrectly used as a mathematician Legendre's portrait for centuries before the error was discovered. And like Gauss, he was interested in calculating ellipses and the curvature of cannonballs shot from cannons. He also helped to develop the metric system, as well as create logarithmic conversion tables. Independently of Gauss, he wrote in 1805 Nouvelle méthode pour la détermination des orbites des comètes, which laid out the least squares method. Least squares has a background in calculus, so we should note the twin inventors of calculus who worked independently of one another. Gottfried Wilhelm Leibniz was German and was an immense intellectual and social personality who traveled widely in diplomatic circles, especially the court of Hanover. He was such a busy man he invented calculus in his spare time. Sir Isaac Newton, independently of Leibniz, invented calculus, among other things such as the law of gravitation, over a several-year period in England, which coincided with his self-isolation in a cottage in Lincolnshire due to the plague, rather like many of us are doing during COVID-19. Quarantine didn't slow Newton down, it seems. Here's a picture of his home with the famous apple tree of lore in the foreground. The story, of course, is that Newton was sitting under the apple tree when an apple fell off of it and hit him in the head, instantly enlightening him on the workings of gravity. In reality, as best as we can trace it, Newton observed apples falling off of the tree and inferred the notion of gravity from his observation. Speaking of homes, by way of a personal introduction, I've been teaching at Boise State since 1997 and have taught this course a lot since 2002. I'm from upstate New York, living close to New Paltz, a college town at the base of the Shawangunk Mountains, and Kingston, a small city on the Hudson River. I earned my undergraduate degree from the University of North Carolina at Chapel Hill, the oldest public university in the United States. I earned my doctoral degree from the University of Iowa in Iowa City, the first coeducational public university in the United States, and the first university in the U.S. to award a Black American woman a doctorate in political science. My doctoral dissertation at Iowa used regression analysis to estimate the relationship between economic development and democracy. I found that the relationship is a causal one, meaning that higher levels of economic development cause democracy to increase in countries around the world. Over the years, I've published a few articles on this topic and on other topics, again using regression analysis. It is a workhorse for me, too. My family and I hope that this course will show you how useful this method is, and that far from being a repelling endeavor, it proves to be a most attractive way to gain knowledge about political behavior. Welcome to POLS 398.